Now the question arises, is there any sequential questionnaire for pedigree studying as to know what kind of genetic disease it is, or is it any mitochondrial disease? To conquer any pedigree in your exams, you don't need to guess. You just need to ask the family tree 5 specific questions in a fixed order. This is Dr. P's sequential pedigree protocol to reach the diagnosis every single time. Step 1. The generation gap test. The question you need to ask here is, does the disease appear in every single generation, or does it skip generations? If it appears in every generation, think dominant and go to step 2. If it skips generation, think recessive and go to step 3. Step 2. The dominant branch. If you decided it is dominant, ask this question. Does an affected father pass it to all of his daughters and none of his sons? If the answer is yes, the diagnosis is X-linked dominant disease. Logic here is, he gives his only X, the affected X, to daughters and his clean Y to the sons. If the answer is no, then he passes it to a son. The diagnosis is autosomal dominant disease. The logic here is, male-to-male transmission is the gold standard proof that it is not X-linked. Step 3. The recessive branch. If you decided in your step 1 that it is recessive, then ask this question. Are mostly males affected, and is it passed from a healthy carrier mother? If the answer is yes, diagnosis is X-linked recessive. Logic here is, females have a backup X, males don't. If the answer is no, then males and females are roughly equal. The diagnosis is autosomal recessive. Look for consanguinity, the double lines between parents. Moving on to step 4, the maternal only test. This is a special case. You have to ask the question, does an affected mother pass it to all of her children, sons and daughters, while an affected father passes it to none? If the answer is yes, the diagnosis is mitochondrial inheritance. The logic here is, mitochondria comes only from the egg, the oocyte, never the sperm. Example is Leber's hereditary optic neuropathy. Step 5. The Y-linked test. This is the rarest. Question is only males affected, and does every affected father pass it to every son? If the answer is yes, diagnosis is Y-linked, Hollandric. The logic here is only men have Y. Example is hypertrichosis pinnae or hairy ears. This is the summary decision table or the cheat sheet. If you see father to son transmission, it cannot be X-linked, must be autosomal. If all daughters of affected father are affected, likely X-linked dominant. All children of affected mother are affected, likely mitochondrial. Skips generation, but mostly males, likely X-linked recessive. Skips generations and equal male-female ratio, likely autosomal recessive. If you are stuck between autosomal dominant and X-linked dominant, look at the affected father's daughters. If even one daughter is healthy, it is autosomal. If all daughters are sick, it is X-linked.